Let's balance some more chemical equations. Let's react C2H4 plus oxygen. Both of these are gases at room temperature and pressure. C2H4 is a type of compound. It's a hydrocarbon. It's also an organic compound, which is a compound that contains carbon and hydrogen, and maybe just those two, or maybe some other elements like oxygen, nitrogen, or sulfur. And we've got molecular oxygen. And this is going to be a type of reaction that if we burn it, it's a combustion reaction. And so the products of a combustion reaction are carbon dioxide and water. So whenever you burn a hydrocarbon, that means you're reacting it with oxygen. Your products are always going to be carbon dioxide and water. Now, you don't want to leave your car running in your garage. You're burning something called octane, that's a hydrocarbon, because sometimes these reactions don't go exactly as planned. There's some side reactions, and you can make something called carbon monoxide, which of course is deadly. Of course, you can suffocate if you're just breathing carbon dioxide, but carbon monoxide will poison you. Anyway, back to the reaction. So the C2H4 is actually something called ethene. You don't need to know that for any purposes right now, but it's nice to have a name for him. So C2H4 plus O2 makes carbon dioxide and water. Let's balance them. 2 carbons on the left, only 1 on the right, so let's put a 2. 4 hydrogens on the reactant side. I've only got 2 hydrogens on the product side. We cannot change subscripts. We can only change coefficients. So let's put a 2 in front of the water. So now I've got 2 times 2 or 4 hydrogens. So I had 2 carbons, 4 hydrogens, 4 hydrogens. I've got 2 oxygens on the left, but on the product side I've got 2 times 2 is 4 oxygens from the carbon dioxide plus 2 times 1 are 2 oxygens in the water. I've got 6 oxygens on the product side. 4 oxygens in the carbon dioxide and 2 oxygens from the water. That gave me my 6 oxygens. So now I've only got 2 oxygens on the reactant side. So to balance that out, we're going to put a 3 in front of the molecular oxygen. So now I've got 6 oxygens on both sides. 2 carbons, 4 hydrogens, 6 oxygens, 6 oxygens, and it's balanced. Let's take C2H6. That's a gas, and it's called ethane. Just 2 carbons, ethane, plus oxygen. Reacts to make what? We got a hydrocarbon, burning it with oxygen to make carbon dioxide and water. So let's balance our atoms. 2 carbons on the left. I need 2 carbons on the right. 6 hydrogens on the left. I've got 2 hydrogens in the water. Can't change the subscript. I can only change the coefficient. We'll put 3 out front. That gives me 6 hydrogens on the product side. I've got 2 oxygens on the reactant side. On the product side, I've got 2 times 2 or 4 oxygens in the carbon dioxide and 3 oxygens from the water. That gives me 7 oxygens. So I'm not balanced. So one of the ways I can balance this now is put a 7 halves in front of the O2. So now I've got 7 halves times O2. The halves cancel out. I'm left with 7. And so that will now give me 7 oxygens on the reactant side, 7 oxygens on the product side. That's okay to have a coefficient that's not an integer. A lot of times, just to make things look nicer, we prefer to have everything be an integer. And so to do that, what we can do now is multiply everything by 2. Everything by 2. In which case I'm going to have 2 C2H6. So 7 halves times 2 is 7 O2, that's a gas. Reacts to make 4 CO2, that's a gas, plus 6 H2O, that's a gas. So I've multiplied everything in this equation by 2 at this point, and that got rid of my half. Just to prove that my atoms balance, I've got 2 times 2 are 4 carbons, 2 times 6 are 12 hydrogens, and 7 times 2 are 14 oxygens on the reactant side. On the product side, I've got 4 carbons. In terms of oxygens, I got 4 times 2 or 8 oxygens from the carbon dioxide, plus 6 times 1 is 6 oxygens from the water, so 8 plus 6 is 14 oxygens on the product side. And then my hydrogens, I've got 6 times 2 or 12 hydrogens. So everything now balances. So you can either leave things as a fractional coefficient, or you can multiply by 2 and bring everything to where it's an integral coefficient. Let's do another equation like this. Let's do something like CH818. This is a compound called octane, and you might be familiar with it. And that when you hear the octane rating of the gasoline that you put in your cars, it's actually a mixture of different types of octane. This is a special hydrocarbon, straight chain hydrocarbon called octane in this particular example. Let's do a combustion reaction, which means we react it with oxygen to make carbon dioxide and water. So let's balance it. 8 carbons, I need 4 in front of the CO2. Excuse me, 8 in front of the CO2. That gives me 8 carbons on the product side. 18 hydrogens. That means I need a 9 in front of the water. That gives me 18 hydrogens on the product side. I've only got 2 oxygens on the reactant side at the moment. Right now I've got 8 times 2 is 16 plus 9. That gives me 25 oxygens on the reactant side. On the product side, excuse me. So that means I need a 25 halves in front of the O2, and that will be balanced. Or we can multiply everything by 2 to give us 2 CH818 plus 25 O2 reacts to make 16 CO2 plus 18 H2O. So let's see if this is balanced. I've got 2 times 8 are 16 hydrogens, 2 times 18 are 36 hydrogens, and 25 times O2 is 50 oxygens on the reactant side. The product side, I've got 16 carbons. I've got 16 times 2 is 32 plus 18 oxygens from the water. That gives me 50 oxygens. And I've got 18 times 2 is 36 hydrogens. So 16 carbons, 36 hydrogens, and 50 oxygens. And voila, it is all balanced. It's a trial and error method as we go through balancing these chemical equations using the law of conservation of matter, where we have to have the number of each type of atom being the same on either side.